Hello, guys. Hello, everybody. Welcome to today's session. We will be starting the session very soon. A lot of people are joining in as I speak, so we'll wait for a couple more minutes, then we'll start the session right away. In the meantime, you can use the chat box for any kind of queries or questions if you have during the session. You can ask them in the chat box. So just to make sure that the chat box is working properly, can you guys actually introduce yourself and like tell us what domain are you coming from and how many years of work experience or are you a fresher? Can you please let us know that in the chat box? Let's make this as interactive as possible. Hi Vinayak, how are you? Please tell us more about you. Oh, 10 years of experience in marketing. Great. Hi Shilajit. We have a few more people joining in as I speak. So for everyone who just joined, you can use the chat box for all kind of communication. If you have any queries or anything during the session, you can actually address it in the chat box and we will be addressing all of these questions towards the end of the session. Hope all of you guys are having a really good evening. We will be starting the session in the next 2 minutes itself. So please hang on tight. This is going to be a very, very interesting session, guys. You'll get to know a lot of new things. So in the meantime, please let me know, have you guys any idea about like predictive customer analytics? Please let us know what you expect out of the session as well. Use the chat box, guys. If you have any questions, you can use the Q&A box or the chat box also. We will be addressing each and every questions. And to all the new people who just joined now, we haven't started the session yet. We will be starting very soon. Hello, Harish. Hello. Hello, Omkar. Hi, Asha. Good. We are having a really good number right now. We will be starting exactly at 6:05 itself. Hope you guys are really excited. So, hello guys, hello everybody, and welcome to a session on From Data to Decisions, a masterclass on predictive customer analytics. My name is Abhinand, and I will be your host for today. In this session, you will see predictive analytics in action, how companies actually boost their retention and all. You will learn, you will discover the key skills and roles as well. And you will also know how to fast track your career with certain programs, with like hands-on learning and expert mentorship with weekly live session as well. Stay till the end of the session. You will be getting a session recording, and we are having some very, very interesting thing to give to you guys because it's Diwali weekend, everything is coming up. So we have very exciting things which we want to showcase with you guys. So please stay till the end. In the meantime, let's start with a very quick poll. So I just want to know what was your motivation to join this webinar today? Are you guys exploring career options in data science? Do you want to upskill without learning how to code? Or are you actually considering enrolling in any data science course which will actually enable you to get a better career? Or are you just here to learn something new? Just let me know on the chat box, on the poll, guys. Do put in your votes in the poll. Amazing, amazing. We have few more people. I'll just give you guys a couple more minutes to put in the votes. Please to participate, guys, everyone. Let's make this very interactive. Uh, we really want you guys to take something out of this webinar. We want you guys to learn a lot. That is what we abide by. Do let us know, guys. Like, what was your motivation? Why this webinar? Hi, Ramesh Sangapan. Do vote, guys. Do vote. Let me know. I can notice that we have a few more people who joined in right now. You might be late for the webinar, but definitely not for the data science world to start a career. You guys are pretty early. So we haven't started the session yet. We are just starting some just the poll right now, which is an introductory session. So please do put in your votes in the poll. I want to know what was the motivation for you guys to join this webinar today. Let us know, guys. Also, if you guys have any questions, any queries, please do use the chat box to communicate to us. We want this to be very interactive. We want to address your questions. We want to know your concerns. All right, guys, I'll give you like 1 more minute. Then let's just start the webinar. All right, guys, I hope all of you guys are ready to join. We will start this right now. We'll start at 6:10, exactly at 6:10 itself. The meantime, again, like we have even more people who joined in right now. So, guys, do put in your votes in the poll. We are going to start the session right now. It's right on time, if I may say that. The new journeys again, I'm reiterating any questions, any queries about what we are teaching you today. Please do put your thoughts or like queries in the chat box. We will be addressing them. Make sure you guys get something out of this. Perfect, guys. We'll start the session now. So, before I hand it out to our speaker, a very quick intro to great learning. So, we are India's leading edtech platform that has helped 18,000 plus professionals switch careers through industry relevant and expert led programs. We have university partners like IIT Bombay, MIT, and we have trained over 12 million learners across 170 plus countries. We have delivered 400 million plus learning hours, and we have earned a rating of 4.8 out of 5. Now, I'm very thrilled to introduce our speaker for today, Mrs. Shelton Maharesh. With over 16 years of experience in data and AI, including more than 11 years as a hands-on data scientist, Sheldon has led AI and data teams at Fortune 10 companies and major global brands, bringing deep expertise in developing intelligent AI-driven products. Since 2018, he has been associated with Great Learning and he has mentored close to 1,000 individuals across 35 batches. And currently, he serves as an AI/ML mentor for Deakin University programs while pursuing doctorate in business administration. Over to you, Sheldon, sir.
Hey, do you hear me loud and clear? Hey, nice to be with you all. And I'm very glad to host this webinar. And I'm just seeing a lot of interesting comments and questions coming on the chat. And I hope this webinar will be of great help to you. And I'm just going to take over the screen. Just a moment. Yeah. Let me know once you see my screen right away. Yeah.
Yep, your screen is visible, sir.
Good. Perfect then. Okay, so today the webinar topic is about really about predictive customer analytics. So what does this predictive word stand for? So I'm just going to look into the chat and then you can put your words right there. Okay, and meanwhile, I'm going to give you a very layman example. As soon as you see the word predictive, what is that strikes your mind? Future. Okay, that's a nice interpretation. Calculating what, Asha? Can you be specific? Yes. Future, I like the word. Forecasting, yes. Okay, and I can compare this to, let's say, the weather reporting that we have, right? Have you ever seen a weather report? The weather report is always broken down into three different segments. And then you will see the first half of the weather reporting talks about what has already happened in the past, right? It's like they would say that, hey, yesterday the rain was around this much, we had thunderstorms, then there was flooding, there is heavy temperature, there is hotness. All these things they report about the past. Is this prediction? No, not really. This is not prediction, but this is more about insights, right? We report about something about the past. We call them as traditionally this is under a topic which is called as descriptive analytics, where we describe about the past. Okay, and in the same weather report there is a section 2. Have you ever noticed this? They would say, hey, looking at what happened in the last few days, looks like there would be a continuous rainfall tomorrow or day after tomorrow. They would say that there could be a cloudy sky 2 days later, right? And this is more about the future, or it's more about prediction about something that hasn't happened. But just because of the previous day's data or the previous historical data that has happened, they monitor it and then they are able to kind of predict something for the next few days. It could be forecasting when it is with time. So they say that, okay, at 2 o'clock, it's going to be like sunny. At 3 o'clock, it's going to be at this climate, and so on and so forth, right? So the word predictive is very critical here. And in the same weather report, section number 3 is about prescriptive analytics. What is prescriptive analytics? They say that, hey, since we predicted that tomorrow it's going to be a thunderstorm, better you can go, better not go outside. Or they would say that, hey, since it's going to be thunderstorm, better all fishermen should not go to the sea for fishing, right? And this is very interesting because whenever we talk about descriptive analytics, we are talking about something in terms of something which is very reactive, right? Because something has happened and then you are just reporting or learning from the past data. And traditionally this has been under the science which is called as, or technology which is called as um, are you not seeing my screen? Sorry, I see Vinayak saying he couldn't see my screen. Yes, of course I'm sharing my screen. Yeah. Okay, so you would still see the title, but we will go down the slides. Yeah. So this reactive approach has not helped businesses so far. Let's say, for example, today's topic is about predictive customer analytics. Let's say a business, you are running a business. Let's say you are running a hotel business. Okay, do you find it fair enough that you are a growth manager or the manager who's taking care of your company's growth comes and says every week, sir, last 2 weeks we have lost around 50 customers. This week we have lost 20 customers. This is typically a reporting structure where someone is coming and reporting to you what has happened. And maybe you can get a little bit of insights about your customers. You might find that the customers who don't come back to your restaurant are people who were not satisfied with the food, or they were unhappy with the delivery time, or maybe they found a better restaurant nearby. All these things are very reactive. But imagine you being a hotel manager or a managing director of the hotel could strongly predict. Okay, so before even they could decide to leave your restaurant or not come back to your restaurant, you kind of can predict who are these people who will not come back or will come back to your restaurant. Okay, so say for example you predict that, hey, I predict that Asha is never going to come back to my restaurant because of reason that she finds the prices high. You predict it. So what can we do? It's like typically you can be more proactive, and then you can say that, hey, I'm going to give out an offer, or you will try to make something different, which is prescriptive analytics. Yes, and you try to modify the outcome. So today we are going to look into one of such interesting use case. But before that, you need to know few things about what and how we can do this. And typically this predictive analytics is something that we can do with data science. And in data science, we have a specified field which is called as machine learning. So what is the machine learning here? The machine is going to learn patterns, and using the pattern, the machine is going to do a prediction. I will ask a quick question. Just looking at the chat data, do you think I can predict who will answer my next question and who will not? Of course I could predict, right? Because why? Because so far people have responded. For the last 17 minutes, I see there had been a lot of responses, and I can very confidently say that for my next question, Harish would answer, and Asha would answer, and Avinash would answer, right? Why? There is a pattern, because I could see some people are responding, some are staying calm and listening to the webinar. And yes, I find a pattern, and then I can predict it, right? So the same thing applies, and I'm acting like a machine learning model. And then I will give you one more example for you to understand what machine learning algorithms are all about. Have you ever, um, have you ever been to a gold shop, jewelry shop? Yes, everyone would have gone, right? All Indians, most of the time. So when you are in a gold shop, have you ever noticed that some people get a very special treatment? They will be getting some nice drinks, or they will get some cool drinks, coffee, or even samosas and vada coming to them. And few people don't even get anything. Why do you think so? And you are also looking for a similar jewelry. Maybe you're not treated fair enough, but some people are very specially treated. You know what? I would say that it's not tactics basically, but it's more about machine learning here. So let's say the sales agent can predict, easily identify who are really buying customers and who are all not buying customers. It's not about high value or low value. Even some people who are just going to buy a small ring, they would also get this, but some people don't get it. Why? Imagine the person is like a machine learning algorithm, and they have got some lot of experience over the years. They might have run the shop for 10 years, 15 years, and then with the experience they have got a lot of data in their mind, right? Can they predict with some signals who are really interested customers who would buy something versus who is just doing window shopping? Yes, you can. And what are the signals? What do you think are the signals that they might use to predict who will buy and who will not buy? The body language of the person, the way you ask questions, and let's say the way they, when you say something or present some jewelries, they looking out or not even looking at the sales agent, and people negotiating. Yes, that's a good point. The more they negotiate, can we say that they are more interested in the product? The more they ask about, hey, do I have a different color, can I have this kind of design, etc. Exactly, right? Checking about the gold price. All these things are clear indicators that can help us in predicting. So apply the same thing here. So today the use case is about using machine learning. So machine learning is nothing but a box. It's a mathematical formula that can connect these signals to an output. Is it simple? So what are the signals? Like body language, people inquiring about the price, etc., etc. There are like multiple. Imagine you can put an Excel sheet with rows and columns, and then all these data are put in rows and columns, and then you are trying to predict based on all these things, did they buy the product or not? And then you have this in a tabulated form. And let's say a formula is in the middle, which can kind of associate this back to the prediction. Okay, I hope that's clear. So this is what we are going to see today. So what we will focus on is two things. We will also see towards the end how we are deploying such a model. So we are starting with an introduction to the classification algorithms. What does machine learning mean? What are classification algorithms? We will take a use case and then we will deep dive into how we are solving this use case using machine learning. And towards the end, we are going to also see how it is deployed as an app, okay, as a free app, so that you could also predict something. Okay, real quick. So as I said, you have got training data. So what does training data mean? Anything that is historically present as a data that you can use to predict something is called as a training data. So I can give you an example. I have a 7-year-old at home, and in the 7 years, I have known my kid very well. I know how he would react, how he would, at what situation he would cry, what situation he would be more adamant, etc. Can I call that as a training data? Yes. And typically, the next time when I'm going out, I could even predict using my machine learning. So, machine learning here refers to my human brain. I could easily predict this is the time that he's going to throw some tantrums, or I know that this is exactly the time he's going to cry because, or he's going to be adamant. I could easily predict that and apply the same concept to digital data now. When you are on Amazon as a website, do you think Amazon will already know that you are an interested customer in buying a product? Do you think they can predict it? If they have some historical data about you. Okay, I can give you an example. Maybe they are recording this information this way, and this is purely with your acceptance. You have given some consent, and then Amazon is storing all your click data, right? So Avinash is there, and then Avinash usually comes, visits a product page. He just reads up and down, and then he always buys the product. So simple. So number of clicks, average number of clicks that he makes before buying a product is 4 clicks, 10 scrolls, and then he just visits the review page once and then he buys it. This is a pattern of Avinash. Maybe some other person is like, they come back to the same product 20 times, only then they buy it. With this, I can kind of consider the data historically, and that's my training data. And I'm going to put it to my machine learning model, which is just a mathematical formula. Okay. And then I can give you an example of that. So let's say you own a car, okay? And then I can have a graph like this. You want to predict mileage of your car, okay? Mileage of your car. So historically, your car has given mileage like this. When your average speed was 20, your average speed was 30 kilometers, 40 kilometers, so on and so forth, 90 kilometers, and then 120, okay? You have a data like this. I know the scale is uneven, that's fine. And this is all the mileage, miles per liter, okay, or kilometers per liter, okay? You are getting some 15 kilometers, 17, 22, 33, and 40, okay? How will the graph look like if I plot? Do you think it will look something like this? Okay, what do you understand from this graph in one line? Not more ups and downs, it's just one up here. The graph is not visible, really?
Sir, like whatever you've written right now is not actually visible.
Just a second. I think it's because I'm on a project. Now you should be able to see. Do you?
Nope.
Okay. I can write again. Let's see now it works. I think I don't have an unautoed permission. That's fine. Yeah, that's fine. I will manage to. Okay, now you should be able to.
Yep. Yep. 10 is.
Okay, fair enough. So let's say 20, 30, 40 until 100. And then here you have your mileage. Okay, so this is kilometer per liter. Okay, so this is your graph. Okay, so this is 90 kilometers speed. So the one which is on the x-axis is your speed, and then this is miles per liter or kilometers that you get as mileage per liters. Do you see there is a pattern here? What pattern is this? The pattern is very simple. Beyond 90 kilometers, so until some point, your mileage increases as speed increases. Can you say that? The more you increase your average speed of your car, the mileage also keeps increasing, right? So you get until this point. But when you overspeed beyond 90 kilometers speed, the mileage keeps dropping to the end. So can I say that this is a pattern? So I have historical data. So now you are going to start your car. You are planning to go for a travel. And you are saying that, hey, in that road, I would go around 110 kilometers speed. Okay. Can I easily plot using the graph that I have? Can I easily find how much mileage will I get when I go at 95 kilometers per hour? Yes, you can easily plot it, right? I may get a mileage around, let's say, 18 kilometers. Do you get what I'm saying? So this one where you see something like a parabola, yeah, it like a curved one, is usually a polynomial equation. Have you learned algebra? Yes, everybody would have learned algebra, right? So this is a polynomial curve and it has a mathematical representation. The ML model captures that. Okay, so should I go and capture something? Should I go and find it? No, we have Python code for that. And this Python code will help you to find what is that relationship between your input data and output data. And that is what your machine learning is all about. And machine learning usually comes in different flavors. It comes in 3 different flavors. One is called as supervised learning. What is supervised learning? Let's see that. And 2 more, which is called as unsupervised learning and reinforcement learning. So what is supervised learning? When you know there is an outcome, okay, given some inputs, you are predicting churn. So do you have an output? Yes. In the past data, you know these were the inputs and then this was the output, which is a person churning or not churning out. Okay. So given some inputs like the cold range, blood pressure, oxygen levels, we can predict whether it is COVID or not COVID. So do we have an outcome already? Yes, there is an output given there is some inputs. Sales forecasting, given the performance of the company in terms of GDP, the company's overall performance, you are trying to predict sales. So is there an outcome? Yes, there is an outcome. Same thing applies for weather forecasting. Then how different is unsupervised learning? Unsupervised learning means just trying to segment some information into groups. So a very simple example is I have almost like say 100 participants today. Okay, and everybody is listening. Can I group this 100 participants into different categories? Maybe I will use some attributes like, let's call some critical attributes. What are the attributes that we can think of? We can think of attributes like age. Okay, age is one attribute. Can I consider gender as an attribute? Yes, gender as an attribute. Then how many people are, how many years of experience everybody has? Okay, then probably how much of salary they draw. Okay, and probably what is their IQ level, what is their credit score level, something like this. Do you think depending on this data altogether, I can group people into different categories? Yes. So usually these kind of techniques are called as unsupervised learning, where you can kind of segment or cluster your data into some meaningful groups. So maybe today, just looking at your chat interaction, I could just very well categorize this whole group into people who are passive listeners, active listeners, exactly, right, Harish, your point on. So this kind of approach is called unsupervised learning. And then this is a technique that is used in marketing. Have you ever seen that some people always get this call for loan, for giving loan? Okay. And some people only get call for investment. Some people call and say, hey, why don't you invest? And then they never get this call of getting a loan, or and that is because you are segmented. Maybe you are in a segment where they think you need money, and then another segment is considered as a segment where someone has the capability to invest, kind of. So that is unsupervised learning. You don't have an outcome, you just have data, and then with the data, based on the data, you do segmentations. Is it clear? Okay, so now let's take a quick round on a scale of 1 to 10. How much did you understand so far? Okay, real quick so that, okay, not bad, really good. That's good. Okay, okay, all right. So if you understood at a high level, it's more than enough, because then we will come to the next step. Okay, okay, what is reinforcement learning? Okay, reinforcement learning is something when the machine learning model by itself kind of updates its results. So I can give you a simple example for this. um, Say for example, you have this robot vacuums version 1. I'm talking about not the very recent robot vacuums, but the very first version of robot vacuum. Have you ever seen how they work? This robot vacuums, when they are put on the floor, they just keep going and hitting every spot in the house. And as time goes by, after some months, or let's say after some few days, these robot vacuums never hit the wall. Correct? Why and how? Because these robot vacuums kind of go to every place, and then when they hit the wall, there is a feedback that they get that this is a wall. So they get a feedback, they adjust themselves. So they will say that, hey, at this point there is a obstacle, and then I have to kind of stop going there. Okay, so it's based on a feedback mechanism, which we call it as reinforcement, which is based on reward as well as penalizing mechanism. So if you do the right thing, you get rewarded. If you do the wrong thing, you get penalized. So this feedback corrects the working or the prediction of the model. So say for example, a reinforcement learning in terms of marketing can be like this. So I believe that Harish is gonna leave or stop using my product. Let's say he's using a phone brand, a mobile brand, and then he's going to leave the mobile provider and moving to someone else. I predict this. So I believe that the machine learning believes, okay, if I give Harish 1,000 rupees offer, he will stay. Okay, and I'm giving that, but still Harish leaves. So is it a penalty or a reward? Of course, it's a penalty, right? It's like you did something and then it didn't work, and this feedback comes back and says, for Harish kind of a person, it's not the money that matters. So next time, Harish, very similar to Harish, there is another person coming. I predict that this person is also gonna leave. Okay, and then this time I give them food coupons. Okay, I'm going to give food coupons. I will just say that, okay, if you are with us, you get some food coupons which you can use it in KFC, McDonald's for almost like 3 months. For every time you go, you can eat for 5,000 rupees. Okay, there is no company that gives that, but and you see that it's working for predominant of the people, and this feedback is stored. And this kind of continuous learning is called as reinforcement learning, which is also one of the very niche techniques that we use in the marketing. Okay, so today we are focusing more on supervised learning. Yeah, and this is that same tech stack that is being used in robotics and gaming as well. Okay, and how can we do this? So as we said, the supervised learning space looks like this. So we have models, we have an input feature, and then we have a target variable, which we try to predict. Okay, and this target variable is always influenced by certain input variables. I will ask you a question, and then probably you can think what could be target variables for this. Okay, let's take a hospital scenario. Okay, let's imagine there is a hospital that is there, and this hospital is very specialized in treating in-house patients. Okay, so they admit the patient, and for that admitted patient, they kind of treat them. And now the hospital decides to create something like a readmissions prediction model. So when you discharge a patient, you need to predict how much chances are that this person will get readmitted. First question, do you think this is predictable? Okay, Gayatri says yes. Okay, others feel no, it's not predictable. Mm-hmm. Okay, so I'm gonna write this here. Okay, so I'm gonna use my annotate and then we will write it here. Okay, so we are talking about a target variable where we are talking about readmission and then whether they get readmitted or no. This is what we are trying to predict. So answer is yes, you can predict, because that was my very first data science project that I worked on with Deloitte US Consulting. And the model name is called readmission miner. Okay. So what are we doing with the readmission miner project? We have certain inputs, and based on that, we can definitely predict how much chances are there that this patient will get readmitted. Can you think of what are the parameters that you think can be helpful to predict readmissions? Age of the person, of course. Young people don't get readmitted very often. Yes. Gender, do you think gender matters? Yes, gender matters. Maybe some men are not so specific about taking the tablets periodically correctly. Could be. Historical ailments. Okay, a patient with just diabetes versus a patient who has kidney problem but plus diabetes, who's likely to come back and readmitted? Right, the second one, right? Whosoever is having a diabetes plus some kind of kidney problem is high likely to come, right? So we can also say diagnosis as one of our columns. Yes. What else? Do you think ethnicity matters? If I add ethnicity as a column, is it bias, or can I still consider ethnicity to be one of the input variables? Harish says no, but I think the other way around. Maybe Indians are very prone to some specific diseases, correct? Whereas someone with a brown skin versus a black skin have a different kind of response to certain problems, certain diseases. Okay, some diseases are specific to countries, right? Yes, we love laddus, and then probably we are more prone to diabetes. Yes, Ganesh, you are right. So ideally, even ethnicity could be one of the factors that can influence whether a person is readmitted or not. So this is a supervised learning where we kind of have these signals, and then we can say Mr. Ramesh, who was age this and that, who had diabetes, when he had all these things, was he readmitted? No. Then Mr. Suresh, he had this and inputs, and then whether he was readmitted. So this is what we are calling as training data. Does it make sense? Are we now getting what this supervised learning is doing? So you have a input data, and then you have a output, which is historical. Now using this, we are trying to find patterns, and using the patterns, we are trying to do predictions. All good. Perfect. Now let's move on. So within your supervised learning, there are two types of supervised learning. The method number one is called as regression. And method number one is called as classification. Number two is called classification. So when you predict real continuous numbers, so say for example, you are predicting sales, it is a number, correct? 10 lakh rupees, 20 lakh rupees, 1 crore, 2 crores, it's all numbers. You want to predict how much of items will be sold. That is still a number. So all these numbers and everything that is around numbers is called as regression. When you predict this continuous numbers, it is called as regression. And when you predict labels, so typically whether a person has COVID or not, is it a number or it's a category? Will a person get readmitted or not readmitted? Is this a number or it is a class we are predicting? It's a class, right? We are predicting, it's a label kind of. Yes, it's a label or a class. So whenever you are doing that, it is called as a classification problem. So the customer churn that we are going to see today, given certain inputs, we are going to predict whether this user is going to stay with us or this person is going to leave us. So that is going to come under the category of classification. So we will focus on classification today. And the user statement that we have is called as customer churn prediction. And then there is also this fraud detection, medical diagnosis. These are all some good examples. So whenever HDFC or any bank asks you to re-authenticate yourself or multi-authenticate using a phone number or something, you know what is happening? There is a machine learning algorithm that's running that has predicted you using a classification algorithm, which is a supervised learning model that has predicted you as a fraud. Okay, so the next time whenever you are asked for an additional password or additional something, you have to know that it's because some machine learning algorithm has predicted you as a high threat or a high possible fraudulent person. That's why they are making sure that they are asking for more authentication. Okay, good. So please have your questions coming on. I would also see the Q&A part. So if there is some relevance to what we are doing here. All right. Okay, in classification, what is the key idea behind classification? So we can do classification with multiple algorithms which are available in the open source community. So Python is a very strong programming language. You can learn Python and also do a lot of things in Python free of cost, which means the tool is completely open sourced. So we don't pay for the language. And anything that is developed with the language, we call it as libraries, are also kind of free in the open source world. So which means for developing a machine learning model, do I need any kind of cost for the actual development? The answer is no, but there could be cost that is associated to some storage, etc. But for anything that you do with smaller amount of data, you can do it with complete free resources. Okay. And the best way to start doing something is in a place called Google Colab. So you can just search for it. I will also show you that. You can search for Google Colab, and in Google Colab, you get to write Python codes for free. Okay, it's completely free. And then you can create this machine learning models also for free because Colab is free. Python libraries are also available and accessible on the cloud. And then they give you some good compute. Yes, Jupyter Notebooks you can use, Harish, but Jupyter Notebooks is not a cloud environment. So if you use something like Colab, it's completely on the cloud. So you can use their hosting, their GPU, CPU, everything for free. Okay. So in this space, we are going to try 3 models today. So these 3 models are machine learning models. One is called logistic regression, which is an algebra based model. We are not going to go into the math part of it, but it's a simplistic model. And then we have decision tree. So decision tree is like if else statement, right? So say for example, if it had rained last 3 days plus it is not sunny, tomorrow it will also rain. This is a decision tree. You have a lot of if else conditions, and then finally based on that you have an output. That is decision tree. Collection of decision trees make a random forest. So that is the third one. So what are we going to do is we are going to try these three algorithms to see which of these algorithms is giving me better results. Of course, each algorithm has its own strength, weakness, as well as quite often used algorithms are the ones which are in the bottom. Let's say, for example, random forest is more often used than the other two ones. So we will try and see how these things work. What are the strengths? The simple models like logistic regression are faster to develop, very quick. The development time is very low. The model learns within microseconds. When we move towards the bottom, random forests are very complex in construction. Okay. And logistic regression kind of models will understand only when your data has linear patterns. So something increases, other thing increases. So say for example, uh, if salary decreases, churn means resignation. Let's equate to resignation in a company. If salary decreases, resignation increases or decreases. In simple words, recession also, yeah, your it also increases. Salary decreases, other increases. So is it a linear pattern? Is it a linear pattern or it's not a linear pattern? What do you think? Yes, it's a linear pattern, right? Because when something increases, you have the other one which is kind of inversely associated, but it's a linear pattern. So logistic regression kind of models can only focus on those kind of things. They cannot understand anything which is not linear. Okay, so that's why these models uh, are primitive. Of course, we will see how to find the best model. I had a question on the chat already, which says, how do we find the best model? Yes, we will see. We have to experiment everything. Why is that when someone learns machine learning, they are called as data scientists? Is because you have to experiment. You have to try these models. You have to try things. Okay, let's keep going. So the results of the model can be identified using matrices, which is called as true positive, false negative, false positive, and true negative. Okay, I will give you a simple example. When a customer is predicted to be churning, which means the customer is going to leave your provider or leave the bank, never going to come back as a customer. They are closing the bank accounts with you. That is called churn. You want to predict churn. The true positive here stands for when you predict churn exactly as churn, what happens? It is called as true positive. Okay. So your model is also predicting, for example, we have Ravi Shankar, and I predict Ravi Shankar is gonna churn from this company. And really, Ravi Shankar is churning out. So that is true positive. So your prediction and your actuals are same. All good? Second, false negative. What is false negative? Actually, the customer churned, but the model is predicting and saying no churn. No, it's not. It's saying that no, this customer is not leaving. The model says predicts wrongly, but in the reality, the customer is actually leaving the company. That's scenario number 2. Scenario number 3 is false positive. The customer actually did not leave, but the model predicted as the customer is leaving us. Why do you think the second and the third pillar are a problem? Can anyone think logically why this wrong prediction is a problem to us? Okay, improper data input. I'm not asking the reason for what goes wrong, but why this output is a problem for us. Yes, loss of revenue. Let's say, for example, the customer is gonna churn, but your model is not predicting it properly. So what will you do? You will never be able to know who is leaving your company, correct? Properly, you are not able to capture that. That is pillar number 2. Pillar number 3, the problem is when someone is not at all going to leave. Let's say Ravi Shankar is never going to leave me, but the model predicted that he's going to leave. What will I do? As soon as the model says Ravi Shankar is going to leave, I'm just going to send him 1,000 rupees voucher. Ravi Shankar will be super happy that he got 1,000 rupees voucher. But he's not even going to leave us. Correct? So it's a loss to the company, right? It's like it's a loss. The last one, true negative, predicting a customer who's not churning as not churning. You will not do anything, right? As soon as you know that this person is not leaving, and the real data also says they will not leave, nothing to be lost. What about the first pillar? What will you do for the first pillar? What will you do for the first pillar? What prescriptive step will you do for the first pillar? When you predict, there is no loss, yes, but exactly, you will reward to retain. Correct? You will think about talking to them. Maybe you will call them personally and say, hey, are you satisfied with your service? Have you ever seen this? Sometimes randomly you will get this call, and then they will say, sir, are you satisfied with the service? You have any problems, just tell to me. And usually this happens with bank also. They call and say, I am your customer relationship manager. You can, that is because it has predicted you maybe as a churn person, and then they are trying to retain you with some strategies. Okay, are we clear with this picture? Because we have to get into the use case now. All good? Perfect. So what is the use case that we are trying to do? Okay, so Kodishwaran, I can give you one more example. Let's say we are trying to predict COVID with some input data. So let's say you have built a machine learning model. The model can predict COVID without doing any kind of testing. Whatever test, I forgot the name, let it be. Okay, all the tests that we had, we are not going to do any physical test, but just telling the data about your blood pressure level, oxygen level, how much of cold you have, cough you have. You can just tell whether it is intense or not, and then you are going to put it into your model, and the model is going to predict and say the chances of COVID. Yeah, PCR, exactly, right? Instead of PCR, you are going to rely on a machine learning model. Let's say someone has COVID. Really, they have COVID, and your model is also predicting COVID. Is it good? Yes, it's good. Why? As soon as we know we predicted them to have COVID, you will isolate them. Now, let's say there is a person who doesn't have COVID, but with their data, when you put it to your model is wrongly predicting them to have COVID. Is this a problem or not a problem? Not a huge problem. Why? Not much of, yes, it's little bit of a problem because you will isolate them. You will put them in a separate room and they may feel lonely. But is it heavily a problem, this wrong prediction? Not so much, right? It's not so much. Because the next scenario is really the problem. What problem? The person has COVID, but your model predicted that they don't have COVID. Now, this is the place where it gets tricky. What will they do? Because they had a result from the machine learning model that said that they are not having COVID, they will roam around, they will be everywhere. Correct? They will go everywhere they want. And then this is exactly a problem. So that is what we call it as false positives. Okay, do you get it now, Manikandan? Okay, so let's get into the problem statement. We have a customer churn problem, and then people are with a bank, and then this bank is losing customers. They wanted to predict who are all the customers that can be predicted in terms of churn, because they are leaving to new competitors, and this is mainly a credit card division of the bank, and then we need to predict it. So we are going to use machine learning to predict before even they would leave. We are going to predict them so that we can stop them from leaving the company. So that's a use case that we have. And let's get into how we are creating this model. Okay. So the data set looks like this, as you can see on the screen. So we have a data set for every customer. So this is past historical data. And the historical data shows who are all the attrited customers, which means customers who left, and who are all customers who are not yet left the credit card company, the age of the customer, the gender of the customer, how much of credit value income they have, what is their credit limit at the moment, okay, how much number of transactions are they doing, what is their opening balance, what is their closing balance, etc. Depending on this, we are trying to predict whether the customer is stayed or not, historical data. Now, our goal is to create a machine learning model that the model, as soon as we give these parameters from C till U, you give these inputs, the model will tell whether the person is high likely to churn or they retain. Okay, so that is the use case that we are going to see. So I'm going to use something which is called as Google Colab. So you can go to collab.google.com and then it opens up something like this. So if you have a Gmail account, that's all we need. You can just say open Colab, or you can even click on a new notebook, and then you will get a simplified place where you can write Python codes. This is a very good place also for you to practice Python. If you are very new to Python, you can also type this. So say, for example, 1 + 1, and then you click on execute, it will execute it. So it's on free source. Okay, it's a new notebook, so it takes time. So you can write simple codes like A is equal to 2, B is equal to 23, and then you say A plus B. Okay, so all these things, whatever we can do, we can write it on this notebook, and that's already the notebook that I have developed now. So this is a notebook with a problem statement, and we are installing the libraries that we want. So Python alone is a programming language, but there are a lot of libraries that help us to accomplish the tasks. Okay, especially libraries like pandas is to deal with tabulated data, and NumPy is used for mathematical operations. Matplotlib is a visualization library, and Seaborn as well. Scikit-learn, this one is a library which has all the machine learning models in it. Okay, and to save the model as a file, you need joblib as a library. So these are the essential libraries, and we are installing them. Then once the libraries are installed, I am gonna call the libraries. So it is as simple as saying, like English, I say import this library, and you can give an alias name. Okay, and I'm ignoring any warnings that shows up. I'm connecting to my Google Drive. Okay, because I have the data set in my Google Drive, and I'm loading the CSV. So it is reading the CSV from this particular path. This path is in my Google Drive, and the data is loaded, and it's loaded to a data frame. Okay, and once it's loaded, I'm loading it to a variable called data. So let's check what is inside this data. So I'm just saying data.head, and then you can see the data is already loaded. Whatever is in the CSV is now available here. Okay, all good till now? Can I see a response if you got until now? Okay, good. So we can also quickly check the size of the data frame. So when you say data.shape, it gives you the size of the data frame. So there are 4,000 columns, rows, and then 21 columns. .info will help you to identify if there are any missing values, and it will give you the data type. Okay, so it tells the attrition flag is an object, which means it's a string value. Customer age is an integer column, and no, not null, which means there are not any columns with blank values. So if you have a blank value, it's going to say how many such rows are having blank values. So this is a quick way to see a quick profiling about the data that you have. Next step. So we have this client number as a unique number, so we can maybe drop that as well. So we are doing .describe. .describe is a function that helps you to get a statistical view about your data. So what is the statistical view? So let's take, for example, customer age, right? So totally there are 4,067 information available. Yes, obviously, because we have 4,000 customers available. So for everybody, we have an age column. So that is what 4,067 means. But can you easily answer who's our predominant customers? Is it younger people, teens, or very old people, or mid-aged people? The answer is already there. How do I find it? There is something called mean. What is mean? Mean is average, right? So the average age group of your customers is 46, mid-aged people. Correct? Minimum is 26. So look at this. Is this good for your business? People who come to your bank, the starting age is only 26. So whom are we missing? All the college students are not using your credit card, correct? So maybe that is a business opportunity for you to think about, hey, can I make people from the age of 18 get my credit cards? Correct? Because the minimum age is just 26 according to the data. 50th percentile. So if you have 100 people, almost 50% of the people are less than 46 years of age. And then we don't have more senior people. The maximum age is only 70. So just with this customer age column, can you find two business opportunities? Can you roll out a credit card plan for college students? One. Number two, can you roll out a credit card plan for maybe old senior citizens? Do you think that is a business opportunity? Yes, it is, right? Just with the data, you can get this. But this is not prediction. We are not predicting anything. What is this? Whatever I said now, looking at the past data, what is this called? What is this called? Yes, descriptive analytics. You're right. We are not predicting. Asha, we didn't predict anything yet, right? Looking at the data, I come to some conclusions that is just descriptive. I'm just looking at the data and I'm saying this could be a possibility. Okay, good. And then now let's see how this whole thing is around other categorical attributes. Okay, so most of the time our customers are females, so that is the top. So more than male, we have female customers. And then mostly they are married people, mostly they are graduates. These are all the people groups who are using our data. So we will check quickly the sanity of the data. So the data looks good enough because we are checking for null, and then there is 0, which means no missing information. Let's check the distribution of the data. How many existing customers we have and how much people are leaving the company. So what is the ratio? Look at this. So we are creating the total number of people and we are finding how many people are leaving us. 60-40. That's really huge. So if you have 100 people in your company, 40% of them are leaving to some other provider. Not so good. And then this is visualized using Cbond, the library that we saw, right? That the alias name is used here. And then we are using a count plot. You just need to give which column you are referring to and mention the variable name. So it gives you a beautiful graph like this. And then you can see visually how this is spread between existing customers and new customers. We can also explore who's our major user group. As you can see, that we have more female users than male users. And then you can also see most of the people who are using your credit card are people who are graduates. College students are the ones who are using it less. And when people are so much learned, doctorates and people who are into good knowledge, they are using your credit cards less, which is also a problem, which means intellectual people are not your customers. That's the whole thing, right? Because you can see people who are in masters, and you can also see high school students are also using your credit card much, but that's not reflecting in the data. So which means that people who have just finished high school and not done college, but of age group 26 and above. So basically your group, this data says that your main audience group is people who are not much educated, because that's how the data represents it. Are you getting with me? The highest qualification is high school, yes. Okay, can I get a response here so that we can move on? All good. Okay, perfect. Then let's also try to see how our data is distributed. So what is the bar name? It is called as a count plot. Yeah, so this is a histogram. So when you do it for numerical values, it's called a histogram. So this is a histogram. So we see that most of our customers' age is in the middle, right? So between the age of 40 to 55 something, we are having our customers. And then people who are of senior age are very less. The frequency is very less. And then people who are of very low age, who are of college or some kind of graduates, they are also very less. So typically this graph tells you that, okay, and then you can do the same for other things as well, how long they have been with us, and how many dependents they have, everything. Okay, so then we will get into multivariate analysis. This is something very interesting. As you can see, this graph shows you some interesting insights. What is interesting here? The one here is called as a box plot. And as you can see here, this talks about existing customers, and this is about customers who left. Okay. Do you see any much difference between this and this? Not so much. So the amount of transaction they are doing for is not different between people who are staying with you and not leaving you. But towards the last, you have something called as utilization ratio. What is utilization ratio? In your data, if you see, let's say you have a credit card for 1 lakh rupees. For 1 lakh rupees, how much did you utilize the amount? If you used 50,000 rupees, your utilization is 50%. If you use 60,000 rupees, your utilization is 60%, right? That is what it's plotted here. Look at the graph and tell me, do you find a pattern here? Can you say when the credit card utilization is less, people left the company? When the utilization is more, they stayed with us. You see this? When the utilization was only 20% and below, most of them have left. So easily you can say that whenever they are not using the credit card, they are high likely to leave. But the other side, you see that whenever the utilization, again, this is just a tail, but people who are staying with us are mostly using around 25% to around 55%, at least that range. Okay, so this is a very good insight. So you need to make sure that you are encouraging your customers to use your credit card more often. That's why you are getting all these emails. Are you getting emails that someone is saying, hey, with credit card, you can get this product at a 2% discount, 3% discount? Yeah, so that's exactly what is happening here. Yeah, Tamesh, feel free to drop if you have an emergency, please. Please go ahead. I hope everything is fine from your end. Okay. All right. So we can do this for other graphs as well. Let's see if we have any interesting trends around the marital status. Looks like there is not much of difference. Do you see that married men churn more than divorced men versus single men? Do you see any kind of patterns there? No. Everything looks the same. So there is no much of a difference. Let's look into income category. In income category, there looks to be a little bit of a story coming out. What story? Can you say that when people earn more, the attrition was lesser? You see this last bar? When people are earning 60,000 to 80,000, the number of people leaving was lesser compared to people who were earning less money, less than 40,000. So look at this versus this. There is a difference. Okay. When you don't even know the income level, they were like almost 50% of the people were leaving them, and it is making a difference. Correct. So we have got some insights now. So let's try to use these data points and let's try to build a model. Of course, we can drop something which is not helping us. So in the features that we saw, we can of course say that marital status is not so helpful. in predicting churn because the pattern looks the same for everybody. So it's not a very good indicator to predict churn. So we are going to drop that. And now let's try to build the model. So how are we going to build the model? Before that, let's see if there are any more variables impacting. Of course, the balance that is available in the credit card looks to have a good impact. But other than that, there is nothing. So we will use the inputs. We are going to drop anything that is not useful. So we are dropping the education column. So we are using the keyword called drop. And then anything that is not so impactful to predict churn, we are dropping it and keeping the rest of the data. And we are going to split our data into train and test. What is train and test? I'm going to use some data to train my model, my machine learning model, and some data to kind of test it. Okay. So I'm going to do a process called a standardization where I'm going to standardize all my data into a normal scale. Okay. And then the next step we are trying to do is we are going to put it to a model. Yeah. And yes, of course, you can do one-hot encoding, but we are very selective about a set of features. Okay, so yes, if you have all your categorical values here, we are converting that to ones and zeros here, Asham. Okay, so the next one is we are going to try 3 different models. One is a logistic regression model, a decision tree, and a random forest, right? So we are calling these 3 models, and these 3 models are available in scikit-learn. Okay, and it's, again, as I said, it's free. You can access it directly. And then we are trying to build a model. So how do you build a model? We use the word called train. As you can see above, we are using the word called fit, and then we are sending the train data. So the model at this point learns the pattern. Okay, it learns the pattern. So Chaitanya, so you have many options. So it is not that you have to try these 3 models. You have almost like 20-25 models. You can try everything. Point number 1. Then you can choose whichever is giving the better result. You can kind of confine it. But for the webinar, we wanted to make it simple. So we chose some very basic model, which is logistic regression, and an advanced model like random forest, and an intermediate model like decision tree. But usually you have plethora of models, around some 20 models that you can really try out, which is very, very good performing models. Okay. So we train the model, and then now we are predicting, and then you see that logistic regression is 79%, decision tree is 83%, and then random forest is 90%. So what does this 90% mean? So if 100 people are churning out, 100 people are leaving, using random forest, you can predict or recollect 90% of them. Decision tree, only 83%. While logistic regression, only it is 79%. Now, of course, if you want to put this model into production, you can use some tools like Hugging Face. Today, we are not going to get into how to deploy the model, but it's very simple. You can put your model files here, which is the model that we created, which is churn prediction model. You can save it, and then you can deploy it in free server called as Hugging Face. So Hugging Face is a space which gives you free cloud space to deploy your model, and deployment takes hardly few minutes. So if you think about something, how it would look like in production, it would look something like this. So let's say you can choose the customer age, I can choose the credit limit, and then I'm choosing the gender. Of course, there were many other parameters, but I'm showing just 3 of them. You click on predict. It says what is the probability that they will churn or not churn. Let's say they have a very low credit limit. I predict it. Okay, not churning. Good. Look at this. Is high likely to churn because they have a low credit card limit and the customer age is like 35. Let's keep it to 40 maybe. You see that it has reduced. It was earlier, it was showing some 50, 82%. But for the same credit limit, when I increase the age and click on predict, it's giving me higher chances. I click on predict, it gives me higher chances. And maybe I give more age. It's still higher. Now, with more credit limit and more the age, the probability has turned negative, which means they are not going to leave. So this is like a productionalizing environment. Of course, as I said, this is just a webinar on the main topic, how you can use machine learning to do predictions. Yeah. The random forest 90% is very simple. So if you have 100 people leaving the firm, Kodishwaran, we are able to predict 90% of them correctly. So you are able to predict 90%. So literally, the 90 people who are leaving, not exactly the whole 100 people, but at least 90% of them who are going to leave are predicted by the model correctly. Hope that answers. All right. Okay. So I'm glad I was able to share some good insights with you. It was limited time, but I at least believe you have got an idea how this is done or implemented, right? I'm happy that you had a takeaway today, and then I would hand it over to Abhi and Saud back.
Thank you so much, sir. It was pretty really insightful, to be honest. And if you guys have any questions or something, please do ask right now in the chat box. Any kind of questions, sir will be here for the next 10 more minutes. We will be addressing all your questions. Any questions if you have regarding the topic that we just taught right now? Next, 10 minutes, we'll be moving to the next session. Next session we will be taking you to like how you can actually be able to achieve all of this thing. The session isn't over, guys, so we're just taking a break now. Any question, guys?
Yeah, I see. Maybe I can take a couple of questions that's coming here. So that's like, typically, how do you build models on Hugging Face? Yes, you can create a UI in Hugging Face. It's very less code, Nidit. So you can use Hugging Face to even create a UI. And of course, in Great Learning, we have courses where we are focusing more on productionalizing things. Considering today's webinar was limited to this 1.5 hours, we were not able to show you that. But you can also deploy it in multiple places. So Hugging Face is one, but you can think of putting this on AWS, on GCP, etc. Any cloud environment, you can just put these things. Yeah.
So there's a question, like who is responsible if prediction and actual is different?
Yeah, it's a data scientist plus business domain people. So usually when something goes wrong, we try to see, first we used to tell them the results, right? So we tell to business, hey, this model is 80% reliable. So they already know that it's not 100% reliable, and then there is 20% chances of error. And data scientists will keep on working to make the model better. So you will have version 1 which is at 80%, then probably you will build another version which is at 90% accuracy, etc. You will try to work on it. So never have data science been 100% accurate, because your data will never be having a very clean pattern of information. So that's one thing. Yeah.
Another question from Hari is like, besides Hugging Face, any other portal to predict the model?
Yes, so you can still use cloud-based systems like AWS or GCP, which is Google Cloud Platform, even to host your models. Or you can even host it on your local machine. Hugging Face is preferable because it gives you a place where you can create UI, run your code. You can even deploy your code with GitHub. So that's also a possibility. So these are all cloud platforms where you can deploy your model.
Another question from Chaitanya, like as mentioned earlier, there are 20 to 25 models available. We can't keep trying those many while working in companies, right? So how to filter the 5 to 6
Yeah.
models
So
out of
one
the.
is one is based on your domain. You already know that there are top performing models. I can give you some names already. XGBoost, AdaBoost, CatBoost, and Random Forest. These are all top performing models every time. So usually, what we do when it's by experience, we always try the most promising result models. But if you are new to data science, we always ask you to run through all the models, and this can be done using automated frameworks, Chaitanya. You need not manually run it. So even if it is 20-25 models, you have experimentation codes that can run through all the models seamlessly, which also gives you the privilege to see different results, and then you can choose whichever is performing well. So that is exactly the job of data scientists. So there is nothing to think about okay, what will my company do, etc. That is the work of a data scientist, to experiment as many models as possible so that you can get the best model out.
Another question, like, is Hugging Face actually free or not?
Yes, you have a complete free version of Hugging Face. So just you need an email ID and an account with Hugging Face. You can use Collab and Hugging Face uh, together, and then it's totally free.
One more question, like, is there any parameters that can be loaded in 88 time at a time?
How many parameters can be loaded at a time? So when you say parameters, it depends on the compute. So you can run even a computer vision, which is to deal with images in your collab. So that's not a problem. So, and your hyperparameters and other things are typically manageable with your local machines. If it's for study purpose or research purpose, your free version is more than enough to use it.
Uh, I hope all the questions have been cleared now. Is there any more questions? Please to ask, guys. Asha has one more question, sir. Can you say any other related platforms like Hugging Face?
Okay, as I said, you could host your models even on Kaggle. So Kaggle is a place where you can also try your model, and especially when you're learning something, I would ask you to try platforms like Kaggle as well, where you can also try to see your models, deploy it. Yeah. If not, if you think Hugging Face is so much, as I said, within Google Cloud GCP, they give you some free versions as well. You can also try to deploy your models right there.
Chaitanya has one more question. So he's actually new to this domain. So he's asking, is it better to learn machine learning and then
Yes.
AWS, or he can actually take up AWS before machine learning too?
So I would say focus on machine learning because that will give you foundation. And then if you want to learn something about machine learning on cloud, take AWS or GCP certification next. But learn the foundations of machine learning, then you will know what exactly is needed within the cloud space to deploy machine learning models.
I hope that is clear. Last question we'll take up right now is from Manigandan. He's asked, like, is this use case a example for a real business case
Yes.
scenario?
So what you saw in terms of data, yes, it's a real use case. But what we showed in terms of the UI is a simplified one for you to get a feel of how it looks like. So the use case is realistic, but what we shown you in the Hugging Face, just to make it simple for you to understand, I simplified it with 3 parameters. But in real world, production friendly environment, we use multiple parameters, not just 3 parameters.
So that way, I hope each and every question has been cleared now. So before we move to the next session, thank you so much, Sheldon sir. It is really a very, very insightful session. Even I got to learn a lot right now during the session. Now everyone should be wondering like how they can actually learn all of this stuff up, and like how to practice without data. Obviously, everyone will be actually facing an hurdle right now. So how do we actually face all this challenge? How do we actually upskill ourselves in all this thing? So for that, I'll actually introduce Mr. Mohammed Saud. Mr. Mohammed Saud is a senior manager at Great Learning, and he has over 6 years of experience in AI and data science. He has helped thousands of people make smarter career decisions in tech, and today he'll walk you on how to thrive in the world of data science and AI. Over to you, Saud.
Thank you so much, Abhinan, for the introduction. First of all, I hope I'm audible and visible at the same time, right?
Yes, you're Saud.
That's great. So, first of all, let me just share the screen. Just give me a quick thumbs up. I hope it's visible.
It is visible for me. Can the attendees also confirm if it's visible for you?
Yeah, please confirm,
Uh,
folks, if in case you're able to see the screen.
Please to use the chat box, guys.
Yeah,
Just
yes,
type in
no.
a yes, so that we know that it's actually visible to you. We don't want you guys to miss out on anything.
It's visible.
Perfect.
Right. So, first of all, I mean, the session has been really insightful. I would always say whenever I get a chance to be a part of the session wherein Sheldon sir is there. There's always a lot that I take from what he teaches to us, right? Now, the other important question that will come in a lot of your minds, that what essentially are the factors that you should consider while choosing a data science course or an AI course. So just for all of you know, the session that you people have attended so far was merely like a glimpse of how one of the sessions in the program with great learning is going to look like. Now let me talk about the factors essentially that you should consider before choosing a data science or an artificial intelligence program. So the first most important thing is you should make sure that you are learning the relevant skill which is mentioned in the job description. So while you will be going through the career opportunities that are available in the domain of data science, AI, make sure there are certain specific skills that are required in the job description. These essentially are the skills what market is currently looking for. The second thing what the market is looking for is global recognition, right? So if in case you're learning a course from a globally recognized institution, one thing which is very important that comes without saying is they might have learned from some or the other mistakes that they have made while delivering the course. So the current version to whatever you will be learning will be a lot upgraded. Okay, the red flags out there would be learning from an outdated curriculum or learning from a local player, because it will have limited value across the employers. Okay, the other important aspect out here is industry experts. So whenever you are learning a data science or an AI program, just make sure that you are learning it from the relevant people, those who have a background in the domain of data science and artificial intelligence. Okay, that is something which is very important. The red flag out there is basically learning from a single star faculty, meaning the faculty will not be coming with an experience in the domain of data science or AI, or will not be coming with an educational or professional background in the domain. Okay. Last but not the least, it's important to learn hands-on case studies. So one thing what the corporate is currently demanding in details is they are expecting learners to come with a detailed understanding on how to resolve the situations with the help of tools and with the help of algorithms. Gone are the times wherein over the interviews definitions and theories used to be discussed, right? So these are essentially all the factors that you should consider before choosing the right course for yourself. So understanding the need of data science and AI in the market at the current point, we have come up with a program which is a Microsoft Accelerator program. Now let me talk about why is this program very effective. Okay, so first and the foremost important thing is you will be learning the program, and there is a flexibility in the program wherein which you will be learning at your own pace. Okay, you will have 30 plus hours of expert video content that will be delivered to you in the program, and you will have weekly live sessions with industry expert like the one that you have attended, wherein you will be having the option to re-attend these sessions over and over again. Let me explain the pedagogy of learning to make this more easier for you. So it's like by the start of the week or by the end of the week, we are going to be releasing you with certain content like class recording or pre-recorded videos. So firstly, you need to go through them. Now, once you go through them, for sure, you will be having some or the other doubts and questions. Once you have doubts and questions, you will be having a live session, which is going to be a combination of three things. The first one would be a summarization or a debrief of the topics that you have gone through. The second one would be giving you a real-time case study to showcase how this topic is being used on a daily basis so that you can simplify your work. And last but not the least, you will have the utmost opportunity to unmute yourself and to ask questions and concerns. Now, once this is done, you will be having an assignment, quiz, or a project work on the basis of which you're going to be evaluated. Okay. Now, the duration of the course, if in case you want to complete it within the flow of learning, this course can be completed within the duration of 3 months. Okay. However, we are giving our learners a flexibility to complete the course in the duration of 9 months. Now, let me talk about the flexibilities out here. The flexibility is you can attend the live session over and over again till the duration of 9 months whenever we are reconducting it. Okay, so we reconduct it every 3 to 4 weeks. Okay, so anytime you feel like you are getting a project on a specific technology that was a part of the program, you can come and re-attend those sessions as well. By the way, every session that you are going to be attending in the program is going to be recorded. You can go through these recordings over and over again. There is no limit or no capping with regards to going through the recordings of the session. The program comes with around 4 real world projects. Along with that, there are going to be 20 plus case studies that are going to be there in the program. And this is a co-branded certificate program coming with Microsoft and Great Learning. The course does covers career support, including interview preparations and resume reviews as well. Now, how exactly have we designed the curriculum of the course? So what India's top companies want. So we have analyzed around 100 plus job descriptions coming from multinational organizations like Dell, Infosys, HP, Accenture, IBM, Microsoft, so on and so forth, right? What we have seen in the job descriptions that these companies are mentioning for the domain of data science and AI, they are looking for skills as follows. That includes Python. That's why we are covering in the program. We are covering comprehensive Python, NumPy, and Pandas. They're looking for skills in supervised and unsupervised learning. That's why we are covering regression, tree-based methods, and clustering in the course. They're looking for deep learning basic skills. That's why we are covering neural networks, CNN, and transfer learning. They're looking for NLP and generative AI. That's why we are covering transformers, ChatGPT, prompt engineering, RAGs, and vector DBs. So the curriculum for the course has been designed keeping in mind what exactly is the market requirement, not just the domestic market, but what the global market is currently demanding with respect to skills in the domain of data science and artificial intelligence. So talking about the curriculum, we will be starting from the foundation of introduction to data science and Python. Then we will be moving to data science and artificial intelligence techniques, wherein we will be teaching you Python and statistics foundation, machine learning, generative AI and computer vision foundation, introduction to SQL and model deployment. And there are going to be additional modules as well that are going to be into data visualization using Tableau and time series forecasting. We will also be covering the tools that are going to be into Python, SQL, Tableau, NumPy, Pandas, so on and so forth. So all of these tools that you're able to see over here, these tools are not just being used in the domestic market, but they are being used over the global market when there is any resolution or any problem statement that has to cater to the needs of a problem coming from the domain of data science, artificial intelligence, or generative AI. The other green flag, if you talk about that I mentioned, is making sure you are having hands-on learning, right? So this particular course comes with 4 hands-on projects and 20 plus case studies. Okay, now just to talk about one of the projects out here, which is coming from automobile customer profile analysis. So I'm pretty sure all of you would have heard one of the biggest brand names out there in the automobile industry right now, which is Tesla. Okay, so Tesla as an organization is growing at an exponential rate, and I suppose you people might be also aware that they have recently opened one of their stores or offices in Mumbai. Right now, the question comes in: what exactly as an organization is Tesla doing, and why are they growing at such an exponential rate? So what the thing is, everything, every decision, every step they are taking it on the basis of the feedbacks they are catering from their customers. So uh, the customers, those who are using their vehicles, right, they're trying to extract their data to uncover the customer preferences, what are their behavioral patterns, and any new vehicle they are coming up in the market, they always make sure that the new vehicle is an upgraded and a resolution to the problems that their customers have faced previously. So all in all, what they are doing, they are religiously taking feedbacks with the help of data, and they are trying to make things better for the organization ultimately, right? One of the case study that you will be working on in the program is coming from medical insurance premium prediction, right? Now the situation is, the medical issues that I will be facing being in the northern part of India will absolutely vary. I mean, there might be people in the webinar those who are coming from the different geographies of India, south, east, and west, right? So the medical situations that I will face here and the medical situations that you people are going to face in the different geographies are going to vary. Okay. Now, what medical insurance companies are trying to do, they are trying to understand the data behind what are essentially the medical problems that are happening as per the different geography. And after understanding the data, they are trying to design medical insurance premium policies with better pricing and informed decision making. Okay, with this they are able to sell their policies and they are able to cater to a large segment of customer. Again, how they are doing it is basically by maintaining the data and trying to understand month on month or quarter on quarter basis what essentially will be the problems that the customers of these regions are going to face. Okay, so this is one of the other case study that you people will be working on. Now the other green flag, now let me call it very clearly. In a program, whenever you people are planning to learn, the biggest and the most important pillar of learning is who are the people, those who are going to be teaching you in the course. Okay, data science and AI, if we talk about the base of these domains, it has to do all with mathematics plus statistics, right? So all of these faculties, if in case you're going to deep down on their profiles, one common thing you will be able to see that their profiles will be coming with a background that has to do with mathematics and statistics. So just to call out one of the faculties out here, Dr. Abhinanda Sarkar, he is an ex MIT Sloan faculty that ranks as the #1 institute over the globe for data science and AI learning, and is a PhD in statistics from Stanford University. Okay. Now, what the thing is, the background of Dr. Abhinanda Sarkar has entirely to do with maths and stats. Okay. Even if in case I talk about the situation right now, he is still associated with mathematics, statistics, data science, and AI. Okay, while you will be exploring the faculties or the courses outside, you will be able to see one very prominent thing, that faculties are like they have recently learned data science and AI, understanding the need of the hour, and they have started teaching this as their bread earner, right? So what important thing is to understand is you should be learning from a relevant faculty, right? Now, when it comes to theoretical and conceptual learning, faculties are the best people to guide you with regards to theory and concepts. But when it comes to practical understanding, industry experts are the best people to guide you with regards to how you should resolve a particular problem statement with the help of tools and techniques, right? So these essentially are going to be the industry experts with whom you people might get a chance to interact with. We have Mr. Saurabh Bagchi, who is a vice president at JP Morgan Chase. Then we have Mr. Aniket Chabra, who is a principal product manager at Monnight. We have Onkar Gaikwad, who is an assistant manager at Mahindra Nextwealth, right? So these essentially are few set of industry mentors that we have mentioned over here, and even few set of faculties that we have mentioned, right? We have a pool of industry experts and faculties with whom you people can get a chance to interact with. Now, talking about the career support, we will be starting with career mentoring masterclasses, wherein an industry mentor looking at your profile will be guiding you which path of data science and AI you should proceed ahead with to have the most stable career path. Okay. The second thing is interview questions. We will be giving you a set of questions that are frequently asked questions in the interviews, okay, with which you can prepare yourself well and appear for the interviews. Then you will be having a resume review. So I suppose all of you would have used prompt engineering or chat GPT, right? You would have understood the relevance of keyword, right? Writing the correct keyword will help you get the right answer, right? Now, what the situation is, if in case you will be mentioning the right keywords in your resume, there are high chances that your profile can stand out and you can get a very better career transition, right? This is what we will be helping you to add in your resume. Then you will be having AI mock interviews wherein you can practice and refine your interview skills with unlimited AI mock interviews into different job descriptions, into different domains of data science, AI, and generative AI. So you can practice it n number of times. Last but the most important one is guided projects. So you will be working on 50 guided projects, right? These 50 guided projects are over and above the 4 projects that you will be doing in the program. So what we have came across, the more number of projects and practical skills you will be adding in your profile, the better would be the chances you can crack a career opportunity and you can leverage data science and AI at work, right? So if in case you will be working on these particular projects, there will be high chances that your resume can stand out and you can get into the interview preparation, and ultimately you can go for interviews and cracking your dream career opportunity in the domain of data science and AI. Now, Microsoft Accelerator program, if you talk about, the batch is something which is closing tomorrow. The fee for the course is 45,000 plus GST. That comes to around 53,100 rupees. For you to kickstart your learning, you will be required to pay the initial admission fees for the course, which is 5,900 rupees. As you are a part of the webinar, you are eligible for a scholarship, which is of 15,000 rupees, and it's eligible for the next 4 learners, those who are going to be enrolling for the course. So the final fee will cost you 30,000 plus GST, which is 35,400. If in case you are interested to enroll yourself in the program, you will be required to use the promo code, which is webinar 15. Okay. So you can fill out the feedback form. So I will talk about this as well in the upcoming slide. Now, this is the month of Diwali, right? And we are currently running a campaign, which is Festival of Growth for your career boost, wherein you can secure your 15,000 scholarship seat, right? Now, why you should upskill yourself in the month of October? So there are approx 3x career opportunities that comes up from January to March. So if in case you talk about upskilling yourself right now, you will be aligning yourself for the peak hiring season and you will have all the necessary skills in your profile. Not just that, you can capture new project opportunities as well, right? So as per the historical data, a good number of projects as well as career opportunities or IJPs comes in organization during this specific time. So you can look for either IJPs or career opportunities from January to March or April. Okay. So this is something we have used a source here. We have gone through artificial intelligence jobs.co.in. From there, we have understood there are going to be 3x opportunities that will come up. And if you talk about the other months of the calendar, it's comparatively lesser. So that's why it's very important to upskill yourself and start your learning in the month of October. Now, the people, if you talk about those who will be filling in the feedback form for the scholarship, they will also be eligible for an Amazon voucher of 500 rupees, with which they can enroll themselves in the next 24 hours. And this is eligible for the next 3 learners, those who are going to be enrolling. Okay. Now, let me tell you the steps of how you can enroll yourself. Meanwhile, I will urge the host to share all of you with the link over to the chat so that you people can go over the website and see through the same. When you open the website, you will see an option that mentions enroll now. Okay. Once you tap on enroll now, it will redirect you to a page, which is an application page, wherein you will be entering your personal details and professional details. Okay. Then you have to tap on continue. Once you tap on continue, it will redirect you to a payment page wherein you have to enter webinar 15 as the promo code and you have to tap on apply. Once you tap on apply, you will be able to see 15,000 promo code has been applied, and you will be able to see it over here as well. Waiver of 15,000 applied. Then you check box on the admission fee, and post that you can use the option of pay with debit or credit card or UPI as an option. Once you tap on any of these options, you will be redirected to the final page wherein either you can scan to make the payment, or you can use any of the other options that I mentioned over here. You can even go for debit or credit card EMIs. I mean, it absolutely depends upon the mode that you're willing to choose. Okay. So that's it from my side. I will request the host, Abhinand, to share all of you with the website link. And also, Abhinand, please share the feedback form to all of the learners so that they can fill it and they can make themselves eligible for the scholarship.
If you guys have any questions right now, please to ask. We will be addressing every one of them. Uh, all the links have been shared on the chat box. We urge everyone to fill the feedback form because we are giving exclusive over just for you guys.
Abhinan, please let me know if in case there are any questions.
Yeah,
Learners, yeah,
we'll wait for a couple more minutes.
sure. Please put in your questions and fill in the feedback form as of the time being, so that we can cater to the questions as well that you people have. I'm able to see an overwhelming response over the sheet. Let's wait for a minute and then we will take up questions. Again, I would urge all of the learners to put in any questions or concerns that are there so that we can address it.
We again urge everyone to fill the feedback form because this is an opportunity that you will get to actually interact one-on-one with our expert, and we will be able to direct you to the right direction of what we feel is the right thing for your career at this point. This is an very exciting and very exclusive offer that you're getting. So please don't lose out on this opportunity. Once you fill that, please give me an S on the chat box so that I know that you have filled it. In case we will be winding up the webinar soon. In the meantime, please to fill the feedback form. It's a very, very exciting and exclusive offer. Alright, guys, any questions if you have, please to ask right away. We will be addressing those.
So, Vinod, do we have any questions, any concerns from the learners?
We
At
don't.
the time? Okay, let's just wait for the next 1 or 2 minutes
Yeah.
and we will find out.
If you guys have any doubt about your career again right now, if you can, if you want to ask, please go forward and ask. We will be addressing those. I guess we don't have any doubts, South. We can wrap this webinar up right now.
Sure then.
Yeah.
Thank you so much. I wish you all the best, and you people have been a great audience. Thanks. Bye bye. Good night.
Thank you so much, South, and thank you so much for everyone for attending. Again, reiterating, please do fill the feedback form. And we'll catch you up with another great webinar very soon. Thank you so much.